Okay, so we're working on number 7. And the problem with this problem again is that it doesn't give us everything we need right away. We have to come up with some missing information, especially when they're asking what is the initial size. And you might think 200 is the initial size, but no, that's 200 is after 15 minutes. So what we're going to do is we're going to figure out what is the rate of change from 15 minutes to 40 minutes. So we're going to start from 15 minutes, which was 200 bacteria count, and we're going to go to 1500. And this is e to the exponential growth. R, we don't know, over a time of 25 minutes. Okay, so we're going to figure out what the rate of this bacterial growth is per minute. So we're trying to find out R value, and this is going to be per minute. So over 25 minutes, what is it going to take us? At what rate is going to take us from 200 to 1500? So we get rid of this by dividing 200, 1500 divided by 200 equals to e to the R to the 25. Now, to solve for exponents, and this is the big deal about us working on solving for exponents, we learn how to use natural log to get rid of the e. Let's get rid of the natural log. Use natural log to bring down the e. Get rid of the e. Natural log, natural log, natural log, natural log. Oops, sorry, all the way around. Natural log 1500 over 200 is equal to R 25, and then we're going to just divide the 25 after we plug this into the calculator. Let's go take out a calculator here. No, I forgot. I should have took out the calculator first. All right, let's just save it. Save it. We'll come back to it later. Sure, I can go back and do that. This is not under photo, this is under files. So I have to dig it up now. Oh, it locked me out. Okay, so let's go ahead and first plug in all the values. 1500 divided by 200. We're going to equals, and then we're going to natural log this number. Natural log that gives me a decimal. We're going to divide this decimal by 25. So our R value is equal to 0.080 let's round up 0.6. Okay, so this is the rate at which the bacteria is growing every minute. Now, so someone asked me, what are all the parts? We're using the equation A, or that we can use P. P is equal to P naught e to the RT. P naught is our start. P is our final population. R is the rate at which we are growing, and this is the time. So the time it takes from getting our original to our final population at that current rate. So when I wrote this problem, I said I had 15 to end, 200 to start. Now, at what rate over 25 minutes would I grow from 15 to 40? Right, 15 minutes to 40 minutes over that's 25 minutes to get from 20 bacteria to 1500 bacteria. And when I'm looking at this, my variable I'm solving for is R, and we need that R because nothing here told us what the original value was. So let's go back and set it up now. To find the initial value, we're going to say, hey, at 200 is our final. We don't know what the initial. How long did it take from our initial to 200? It took us 15 minutes at a rate of, that doesn't look good, at a rate of 0.0806. Okay, why are we doing this? We're saying this is my R and this is my T value. I probably could use a couple more decimals to make this a little more exact. Okay, now you can see now that my missing value is my P naught. So to solve for that, we have to get rid of this whole E problem to the right. So we can just divide it. Opposite multiply is divide is 200 divided by E to the 0.0806 times 15 is equal to my initial value, P naught. So 200 divided by, now I'm gonna do a parentheses here on my calculator. I'm gonna do parentheses 0.0806 times 15. I'm going to close it, and then I'm going to exponential this, e that. Now, e changed my decimal exponent into 3.3. We haven't divided yet. I'm going to hit equals to divide those numbers together. Our initial population is 59.69. I'm going to actually round up to 59.70. Okay, rounding up. So that's my initial population, 59.70. So that's how we did all this work just to solve for our first question, because we weren't able to find what my initial value was. They didn't give us my initials. They started off at 15 and they gave us 40, which none of these are my initial value at 0. So we had to go back using what they would give us to find the R, and then we can work backwards from the R. How do I double? So you can start off at any population. You can say what happens from 1 to 2. What happens from 1 to 2? How long does it take me to get from 1 to 2? At a rate of 0.0806. So how long would it take me to double it? Okay, so 2 is equal to e to the 0.0806 t. How do I solve for t? We're going to natural log both sides. Natural log of 2 is equal to, the e cancels out to be 0.0806 t. We can divide this this decimal over. T is equal to natural log of 2 divided by 0.0806. So 2 natural log divided by 0.0806. And then we end up with, it would take 8.599. We're going to round up to 8.60 years. Oh, sorry, 8.60 minutes. So the doubling period is going to be 8.60 minutes. Okay, so the next part is, now that we have our initial, they're asking what is the population after 115 minutes? So if we start off at 59.70, what is the population after e to the 0.0806? And the t-value is going to be 115 minutes. Okay, and this is just straight plugging it in. I'm going to do the exponent first, 0.0806 times 15 equals, I'm going to e that number, and then multiply this new number by 59.70. Now, why am I using 59.70 versus 200? Remember, 200 isn't the initial value. 200 is after 15 minutes. Uh-oh, did I mess up here? Oh, I think I wrote 15 minutes. I should have wrote 115. 0.0806 times 115. And then we're going to e that. And then times that by 59.70. And that gives us a population after 115 minutes of 633,067.30. Okay. Okay, so we have 633,067.30. That's how much that's our population after 115 minutes. And then when will you reach the population of 1200? Now, 1200, so this is my last one, sorry, running out of space. 1200 is equal to our starting population, 5970 e to the 0.0806. And we don't know how long it's going to take us. So for this problem, just like before, solving for exponents, we're going to get rid of the 59.70. Then we're going to natural log that, and then we're going to divide that by 0.0806. Okay, I'll do that over here. So we have natural log of 1200 divided by 59.70. And then we're going to say that's equals to 0.0806 t. So 1200 divided by 59.70 equals, we're going to natural log this, and then divide this number by 0.0806. And it says it's going to take us t is equal to 32.23 minutes. Now, would this kind of make sense? It would take me 32 minutes. Well, if you look at the part that they gave us here, it told us that in 40 minutes, we make 1,500. So in 32 minutes, we would get 1,200. That looks about right. Okay. So this is really a multi-step problem. No one part is actually really difficult. We just have to figure out what we have, what are we solving for, and then how can we use what we've solved for previously to get to my next solutions, to answer what the next question is. So hopefully, as we go over the test for review, a lot of this stuff will seem similar already. Like, it's not hard to figure out. We're trying to solve for W. So a couple ways we can do this is we can do our identity. The circle of logs, 8 to the negative 2 power is equal to W. Negative exponents means it's on bottom. And that becomes 1 over 64. Okay. So make sure you show the work. Just magical answers, don't cut it. Like if you just write that answer and you write 1 over 64, I'm not gonna give you credit for it, okay? As you can see, I had to go through some work to get there. Okay, a similar problem. The circle of logs, 2 to the second x power is that. 2 squared is equal to 6x plus 6. 4 is equal to 6x plus 6, minus 6 minus 6. 6x is equal to negative 2. X equals to negative 2 over 6. This is negative 1 over 6. 1 over 3, I'm sorry. Okay, 1 over 3. Now, would this answer work? Does the answer make sense? The log base 2 of 6 times negative 1/3 plus 6, does that equal to 2? This becomes negative 2 plus 6 is 4. Log base 2 of 4 is 2. Is that true? 2 to the second power is 4. Yes, it is. Never would have guessed that. Okay, next problem. This one, we would need a calculator for this one because think about the multiples of 6. 6 times 6 times 6 times 6 times 6, right? Does that become 44? We know 6 squared is 36, okay? So that's not gonna work for us. So we're gonna have to use logs here. Let's go use logs. You can use either identity, log base 6 of 44 is equal to x, or if not, we can solve this algebraically by saying, hey, I'm solving for exponents. Let's use log on both sides. Log of 6 to the x equals to log of 44. If you remember, logs bring down exponents. Those go in the front. X log of 6 equals to log of 44. Then we can divide log of 6 because that's just a number. That's some decimal number. Log of 44 divided by log of 6. And now I type that into my calculator, which I can't pull up because it's a screen share. Right. So let's go ahead and I can pull up here. So we're saying what is 44 log divided by 6 log equals, and then 2.2. So 6 to the 2.21, so 2.22 power. 6 to the 2.11 power. This is approximately 44. Okay, they wanted 4 decimal, I'm sorry. 4 decimal points would be 119, rounding up, so 120. 120. Solving for exponents. Six xy 2.1120. That gives us approximately 44. Cool. We learned how to solve for exponents in Algebra 2. Our next problem here is looking at natural log. So we have to know how to deal with natural logs. So a natural log, sorry, I should set up e to the 4x equals to 13. We're natural log both sides. So just a reminder, if you don't remember, natural log of e cancels out, leaving me 4x. And we can divide now by 4. X equals to natural log of 13 over 4. Now be careful when you're plugging this into your calculator, you're taking the natural log of only 13, not the 4. So don't do 13 divided by 4. 13 natural log divided by 4 is our answer. And they want, they don't tell me how many decimal points, so you can use 2, 3, 4. Okay, write the equation in exponential form. So this one, just rewrite it in exponential form. So what's the base? Log base t of v is equal to a. And this is where my circle of logs comes in. T to the a power is equal to v, a. Right? So that's our exponential form. That's what they want you guys to remember. Circle of logs. Convert this. We just did this in our last problem. They want us to use logs. Sure. And they want us to round to the 3 decimal places. So to do this problem, we're going to say log of 6w is equal to log of 1939. When I log both sides, the w goes to the front. W log of 6 equals to log 1939. So if you guys are taking the SAT this weekend, make sure you know your logs. That's on the test. W is equal to log 1939 over log of 6. Right, and that's all just calculator work. Round to 3 decimal places. Okay, we're looking at populations now. I feel like this question is in the word problem question that you guys had for your last homework. So the population in a certain region has an annual growth rate of 4%. So they told us 4% per year, okay? Which is 0.04, okay, 4 cents. It is estimated that the population in the year 2000 was 5,100. Okay, so what's the equation for us? Since they want us do the growth rate, annual growth rate, we're going to do the initial population of 5,100. No, darn it. 5,100 times 1 plus 0.04 to the t power. That's our equation. What is the estimate for the pox population by 2008? That's 8 years later. So it's going to be, sorry, do the math. P is equal to 5,100. 1 plus 0.04 is $1.04. And we're doing 8 years. So the only next thing is you having problems, maybe typing that in a calculator. For me, I would type, you could type it as you see it if you have a nice fancy calculator, or you're really good with your calculator, or you just type this first exponent and then multiply that answer by 5,100. Okay. 1.04 xy, or what's our exponent? We said exponent is going to be 8. Xy 8, that's the number of years, and multiply this by my original population, 5,100. We end up with a Fox population of 6,979, rounding up 6,980. Okay, compounded continuously. So the big deal is looking at the words. Continuously is our equation PERT, P e to the RT. So that's how much we have. So continuously is this key equation. So if it's a continuous equation, we're using the E, using exponentials. So A is equal to, we're starting with $2,000. We have a rate of 0.08%, and we're going to put this in the bank for 15 years. Really it's just filling it in, knowing which equation to use. So for me, it'd be 0.08 on my calculator times 15 years. Then I'm going to E this number. And then once I eat it, I'm going to multiply this by our original $2,000. So after 15 years, we're going to end up with $6,000. $6,600, that's pretty good, right? 8% interest for 15 years. If your parents start saving for college, you can have some money. Okay, this is similar to what we just did in the beginning class. Let's go ahead and skip that one. So this problem here is just for you to set up. We start off, he deposits $1,200 at the beginning of the year of our savings. The rate is 3% compounded quarterly. So a couple numbers here. Quarterly means 4. 0.03 is our interest rate, and our initial P naught is 1,200. So our 1,200, our rate is 0.03, and our N is 4. And then you're just going to plug it in. 1,200, 1 plus 0.03 over 4 to the 4 times, how many years we said? 8 years. 8 years right there. I was looking for that. That would give us our, in this case, what they call ST. I just usually call it A for account. That's all my money in my account. Okay, so let's go ahead and plug this to the calculator. So I want to actually type 1 plus, oops, sorry. 1 plus, and I'm going to divide the percentage. So I'm going to use my parentheses just in case. 0.03 divided by 4. And that's my annual percentage rate. No, my quarterly percentage rate. We're going to take this XY, and XY we're going to say 4 times 8 is 32. That's the number of times I get paid this percentage rate. And then we multiply this growth rate by our starting value. And we have a lot of money. Super fun stuff. This problem is always a little confusing because they don't tell you half. They tell you, in this case, if you read it, it says 25%. Now, what that means is you can either automatically know it's 0.25 is equal to e to the whatever number, or you could say, hey, if I start off with 100% of the tree and I want to get to 25%, no, sorry, not 25, I want to get to 25, right? That's 25% of it. When you do the math, e to the blank, this will be 25 over 100 is 0.25. E to the, now let's fill out the rest. It says the half-life, we don't know our R and we don't know how long it takes. And that's my problem. We are not given the rate and we're not given the amount of time it took to get to 25%. The question is, how long would it take me to get there? Now they did give us some extra information. They told us the half-life of the carbon-14 is 5,730. So on the side, let's go over here, figure out what is the rate of the decay. Once we find the R, we can solve for the T. So if you're in physics, you know it's just this equation. 1/2 equals to E to the K. We call it K, which is our R value. Let's call it R. R and T is going to be 5,730. All these equations are the same equations using different variables. We can natural log, but how did they get this 1/2 in front? It's because if I start off with any amount, we always cut it in half, right? So if I divided 50 by 100, it was going to be 1/2 anyways. So you can just start off at 1/2. Natural log of 1/2 equals to R of 5,732, 30. What happened to the E? Remember, if you natural log both sides, the E and natural log take care of themselves. Then we're going to divide this by 5730. So natural log of 1/2 divided by 57/30. Now, if you look at me, I'm always writing a lot of this work. If I don't see the work on KB, can't give you credit. It's like normal. Let's go ahead and figure out what that number would be. So we said 0.5. We're going to natural log this. And then we're going to divide this by 57/30. And this just gives us a rate of, our rate is equal to negative 0.00012009. Okay, so if this is my rate on my problem, we can go ahead and set up again. So 0.25 is equal to e to the negative 0.001209. And then we're trying to solve for what is that t value that would take us to 25%. We're gonna natural log both sides, because why am I natural logging? Because I gotta get to that exponent. Natural log of 0.25 is equal to negative 0.00012009t. Then we're just gonna divide that over. The natural log of 0.25 divided by negative 0.00012009. And that'll give us our time. Okay, so tap that on my calculator. Let's see if I can do it. No, I can't do answers on my calculator. That's just what it is. Crappy calculator. No, I can't do it. It won't let me do it. Well, let me copy it. Oh, I'll copy results. Sure, let's see if it works. So we're going to do 0.25 natural log and then divide it by, I wonder if I can paste it now. Oh, divided by, I'm not sure I can paste it. Come on, buddy. No, divided by, it won't let me paste it. But if it could let me paste it, no, it won't let me paste it. So you guys can do that part yourself. Okay, looking at this problem here, the setup is pretty clear. No, let's do it a different way. I'm gonna pull up one more writing. Come out. Okay, let me do this. It's gonna be 1,000. Oh. Okay, we're gonna write 1,000. 1.06 2 to the t equals to 50,000. So how do I solve for t? Now, as you guys get better at algebra, you'll be more keen to know what to get rid of first. So can I get rid of 1.06? Nope, because it's attached to the exponent. Can I get rid of a multiply? Sure. So if we divide this over, we have 1.06, 2 to the t is equal to, when I divide out the 1,000, it's just 50. Now it goes back to us to solve for exponents. Natural log both sides, or x log both sides is up to you. 1.06, the exponent goes to the front, is equal to log of 50. Divide that over, 2t is equal to log 50 over log 1.06. Let's go type this under a calculator. 50 log divided by, oh, let's clear that. 50 log divided by 1.06 log equals, divide that by 2. All right, t is equal to 33.568700. Right. And that's our answer. That's how long it take me to get from 1,000 to 50,000. I want you guys to understand what this is. 1.06 is 100% plus 6%. That's 106%. So at 6% interest, if you had $1,000 and you could hold it for 33 years, that's a retirement, you could go from $1,000 to $50,000. at an exponential growth rate. Or this is compounded yearly. Wow, that's pretty good, right? That's retirement, yo. We need to buy some good stocks. Okay, the Fox population. I feel like we did the Fox population already. One. The time required to get investment from $5,000 to grow to $6,800 at an interest rate of 0.75, oops, sorry, 7.5 per year, compounded quarterly. And quarterly is 4 times a year, right? Okay, so 6,800, that's our goal. We start off with 5,000. Now, real quick, I was hoping that you guys would actually memorize the rule already, but our starting value times 1 plus r over n to the nt is equal to p. Now, again, if this is super logical, why this is written the way it is. If I'm paid 4 times a year, they're not going to give me that full interest rate 4 times a year. They're going to divide that by 4. And then I don't get paid more often. So instead of getting paid once a year, you get paid 4 times a year. So you have to multiply the number of times you're getting paid by the number of years. So it's 1 plus 0.075 divided by 4 to the 4 times, in this case, we don't know what it is, it's 4t. Because we're not sure how many years it's going to take us to get from 5,000 to 6,800. So like before, we divide it, 6,800 divided by 5,000. Again, by the time you finish all this review, and if you've been doing it and you've been practicing, you should be a pro at this stuff. 1 plus 0.075 over 4 to the 4t. We need to log both sides. I'm going to use log 6,800 over 5,000 is equal to log of 1 plus 0.075 over 4. You could type that in a calculator if you want. Instead, if you want to write instead a decimal number, you can. 1 plus 0.075 divided by 4. That gives us 1.1875. So that's like 1% per quarter, almost 2% per quarter, which adds up to 7.5% in 1 year. Now, something we want to see also, that exponent, that goes to the front. So that's 4t. Now, I'm solving for t, so I'm going to get rid of the 4 and the log. But that seems confusing, so I'd rather just get rid of the log first. Log 6,800 over 5,000 divided by log of 1.01875. Again, you can just write that original problem is equal to 4t. Now, I'm going to actually just do this first and then divide the number by 4. I feel that's always easier. It's less of a mess on my calculator. Here we go. So 6,800 divided by 5,000 equals, and equal that first and then log it. Now log it. Then we're going to divide this number by 1.01875, log that number, equals to combine the fraction. And then we're going to divide this by 4 to solve for t. And so t is equal to 4.138. They want us to say how many decimal places? Oh, they don't ask us to it. So it's going to take us about a little over 4 years to grow from 5,000 to 6,800. I think that's not bad, right? In 4 years, by the time you graduated college, you went from 5,000 to 6,800 in savings. That's good. You're making money. That's not bad. That's why investing money is important for your future. Okay, we're almost out of time. Let's go ahead and finish up a couple more of these. The half-life for radium is 5,000. So it takes the time it takes to get from half to get to half is 1,590 years. If I start off with 500, how many milligrams will remain after 1,000 years? Okay, so the problem is, for these half-life problems, they don't tell me the rate. Now let me show you the equation. It's P is equal to P naught e to the RT. I see the time, I see the starting value, but I don't have the rates. So I can't predict any values for you. So I'm going to set up as, fine, we know this becomes 250 after so many years, after 1,590 years. what is the rate per year? And that's what we're looking for, 1590. To solve this, we get rid of the 500, 250 over 500. We're going to natural log it, natural log that, and then we're going to divide this by 1590. That's the steps that we would do. Get rid of the 500 first, then natural log it, and then get rid of the 1590. Just so that we get the rate. I'm running out of time, that's why. So 250 divided by 500, guess what that is? That's 0.5, right? Natural log this, and then we can divide this number by 1590. So the rate per year is 0.000435. It's a small rate because it took me 1500 years, okay, to just cut in half. So that's why it's a really small rate. Now the next step is for us to now predict how long it would take us to end up with 1000. So, after 1000 years. So if I start with 500, e to the negative 0.000435, and we want to take this to 1000 years, right? And that's how we end it. In physics, we usually use the letter N for these problems, but it's okay. It's just a letter. So I'm gonna take this number, I'm gonna multiply this by 1000, and then that's my exponent. I'm gonna use the right E, then times that by 500. Now, how much would we have left? We would have only 323. Man, that doesn't seem like we lost that much, right? And the reason why is, remember, it's 1590 to get to half. Well, we weren't even close to that. So we didn't end up with half. We ended up with more than half. All right. So I think that's the time that we have for the review. You can actually watch the other questions. The rest are word problems, and you can find those on our last homework.